looking at powers, which is essentially the idea of exponents, right? Have you dealt with any exponents before?
Not really.
Okay, so let's really get into the basic of it here then. An exponent, and this will be our explanation here, is there's like two parts to it. We'll write it in green. We have a base, which is 8, I've written in this case, and the power, which is 3. Okay, and I've just written this randomly, but it's important that we realize that this number is called the base of the exponent, and that this value is called the exponent, or the power. Okay, so a lot of times, you guys probably in class will refer to this as the power, and this is the base, and the whole thing is the exponent. Sometimes this is known as the exponent, though, when you get into higher level math. Okay, but we need to know those definitions. The very first thing we're going to do is we're going to talk about what this actually means. And what this means is our base is going to be multiplied by itself the number of times there is a power. So in this case, it's the number 3. So we're looking at 8 by 8 by 8. Okay. So using that same concept, and I'll write that example down here. So that's the equivalent of 8 times 8 times 8. Okay. I have 2 times 2 times 2 times 2. I want you to write this as an exponent, okay? First of all, what's the base in this question?
2.
Yeah, the base will be 2, so I'll always write the base in blue, let's say, okay? And what would the power of this one be? We'll write it in red.
4.
Yeah, that's right, because there's 1, 2, 3, 4, 2 to the power of 4. Right? And what that means is just the number 2 times 2 times 2 times 2. And we'll talk about how to evaluate that after. Okay. Yeah, and we could. Do you want to evaluate right now? You almost had it there. What's 2 times 2?
2 times 2 is 4. Times 2 is 8. Times 2 is 16.
Perfect. Exactly. So this is also equal to. It's also equal to number 16. So I've written, you notice, equal signs twice. What this means is all of these things are equal. 2 times 2 times 2 times 2 is equal to 2 to the power of 4, which is equal to 16. All those things are equal. Okay. How about this one? I want you to try to write this in expanded form. So this would be equal to what?
3 times 3 times 3.
Perfect.
Which equals 27.
That's right. Excellent job. 3 times 3 is 9, times another 3 is 27. Good, so you've got that idea. Now this is a really tough one. This is a special one, okay? And I'm going to write above it special. Okay, special one. This is a case where this answer will always be the same. Okay? No matter what our base is, if our power, sorry, I meant to do that in blue. No matter what our base is, if our power is 0, it's going to be equal to the number 1 every time. Okay? So I'm going to make one up. Let's say, it's 8 to the power of 0. What does that equal?
1.
1. Okay? 39 to the power of 0. What does that mean?
Why 1 though?
It's always equal to the base of 1. That's a really good question. I'm going to have to think about that, and I'll get back to you about it, okay? Off the top of my head, I can't remember why that rule is a value of 1. I'll think about it and get back to you, okay? So this is a special case. Always remember that the base to the power of 0 is always equal to the value of 1, okay? Now this one kind of goes past grades 7 and 8, okay? And we have a negative exponent, okay? And I want you to think of it like this, okay? Have you worked with fractions before? Right?
Yes.
Okay. Do you know how to turn a whole number into a fraction?
I currently forget.
Okay. So if we were to turn it into a fraction, think of it like, and I'll write it over here. If I had the number 6, if I want to turn it into a fraction, 6 is also equal to 6 over 1. I just put it over 1. It's still the exact same thing. Okay? We have a negative exponent here. I want to turn my base, okay, in blue, I want to turn it into a fraction. So I'm going to put it 5 over 1. And I want you to think of it like this. Okay? So that this base is a fraction, and it's to the power of negative 2. Or sorry, yeah, power of negative 2. Well, the negative we don't really know how to evaluate. Okay? But I can simplify this by flipping my fraction. If I was to invert this fraction, or it's called the reciprocal in math, what would the base be? if I were to flip these over?
The base would be 1 and the bottom would be 5.
Yeah, so we'd have 1 over 5. And what that now does is it changes our exponent to a positive exponent. So when we flip the base, we go from a negative to a positive, okay? And once we've done that, we can apply our rules. Now, I know it's a little hard because our base is a fraction, but have you done any fraction multiplication yet?
No.
No? That's okay. I'll help you with the idea. If I was to expand this, how could I write this in an expanded form? What would it be? It would be the same idea as these. Base times the base. So how many times do we have to multiply the base by itself?
5 times.
1, and then how many, what's the power say?
2.
2. So 5 times or 2 times?
2 times.
2 times, good. So 1 over 5 times 1 over 5. That's the expanded form of that, okay? And I wrote them both with brackets, but I should write multiplication sign because that's what we're most used to using at this time in math, right? So still the exact same thing, but it's 1/5 times 1/5. The exact same idea as before. What I just wanted to show you is how we can change a negative exponent into a positive exponent so that it makes sense to us, okay? So let's kind of recap here. If we have to write something as an exponent, we have to make sure we're multiplying the same base every time. It has to be the same, so we have the number 2. And the number of times it's being multiplied is essentially our power or exponent. When it's written this way, we're just taking the base and multiplying it that many times itself. So in this case, 1, 2, 3 times. If anything's to the power of 0, what's it always equal to?
It's always equal to 1.
Yeah, always equal to 1. And if we have to change an exponent from being negative to positive, what do we do to the base?
You flip it over.
Yeah, you flip it. And you might have to make it a fraction like we did, but you always flip it over and then makes it a positive base. At this point, you've done everything you really need to. I'm going to show you the proof for this, and it's a little beyond grade 7 and 8 math. It's more like a grade 9, 10 concept, okay? I'm going to show it to you. It'd be cool to look at in case you're interested. So I'll quickly show it on the next page. So in order to kind of make this proof, we have to know we have to know some of our division rules with exponents. So I'm going to quickly show you a rule. There's a rule that I'm going to use some letters, okay? If you have x, so the base being the base, okay, x to the power of a over x to the power of b, we can simplify that by writing x to the power of a subtract b, okay? And what that means is I'll quickly write it. Say we had 5 to the power of 2 over 5 to the power of 1. Well, I can write that as just 5 to subtract 1, which is equal to 5 to the power of 1. Okay? So using this idea, again, we'll use our 5. Let's say I have 5 to the power of 3 divided by 5 to the power of 3. Okay? We're going to simplify it. If I simplify it, it becomes 5 to the power of 3 subtract 3. And what's 3 subtract 3?
0. So
0.
it would just be 5 whole.
Yeah, 5 to the power of 0, which we already know is 1. Okay? But why is it equal to 1? Well, what I'm going to do here is instead of doing the simplifying, I'm going to expand this. Okay, I'm going to tell you that 5 to the power of 3 is actually equal to 125. Okay, divided by 125. Well, what is any number divided by itself? Do you know?
Any number divided by itself is 1.
Is 1. Okay, so what this is showing is that these are the exact same thing. Okay, really, when we create the 0, it's like dividing a value by a value, okay? This is kind of an expansion. So this is a proof to show that anything to the power of 0 is 1. That's kind of an idea that's far from our grade 7 and 8. But, you know, it's cool to see things anyways. Let's show both our pages, okay? It's good to learn things that are outside of our math.